Astronauts float because there's zero gravity in space. Spacecraft heat up upon re-entry because of friction with the atmosphere. And NASA spent millions developing a pen to write in microgravity, while the Soviets wisely used a pencil. We hear these statements repeated as harmless trivia, yet they reveal deep structural misunderstandings of physics that permeate our culture. You can even find these errors printed in university-level geology textbooks. For instance, this passage claims the heat shield of a Mars lander gets as hot as the sun due to friction caused by the atmosphere. The reason we get this so consistently wrong is biological. We evolved on the surface of a rock, surrounded by thick air and a constant downward pull, which makes the physics of a vacuum almost impossible to visualize intuitively. To accurately understand the universe, we have to recognize that our terrestrial common sense is actually a biological blindfold. Take gravity. Most of us assume that as you travel farther away from Earth, the planet's gravitational pull eventually runs out, leaving you weightless. But if you measure the pull up on the International Space Station, it is still nearly 90. In reality, black holes follow the exact same gravitational rules as any other celestial body. Their extreme warping of space only happens when you cross an incredibly close boundary, called the Schwarzschild radius. If you were to magically replace our sun with a black hole of the exact same mass, the Earth's orbit wouldn't change at all. We would plunge into darkness, but we would keep traveling in the exact same circle. Gravity is entirely a matter of mass and velocity. It is not a binary switch that flips off the moment you exit the atmosphere. We also project our Earthbound experiences onto heat and light. It makes sense to assume summer happens because Earth has moved physically closer to the sun. The data shows the exact opposite. Earth actually reaches its farthest orbital point from the sun in July, right in the middle of the northern hemisphere's summer. The temperature change is entirely driven by the planet's 23.4-degree axial tilt. During summer, that hemisphere points toward the sun, concentrating the incoming solar energy over a much smaller, more direct area. This reliance on our daily experience is exactly why that textbook got re-entry heating wrong. We rub our hands together to get warm, so we assume a returning spacecraft heats up through atmospheric friction. The true cause is adiabatic compression. The spacecraft is moving so fast it acts like a massive piston, slamming into air molecules that cannot get out of the way fast enough. This creates a cushion of superheated plasma in front of the heat shield. Even our eyes deceive us about the sun itself. Any child will confidently reach for a yellow crayon to draw it, but the sun emits the full spectrum of visible colors, making its true light pure white. We only see it as yellow because our atmosphere scatters away the shorter blue and violet wavelengths. The envelope of gas we live in keeps us alive, but it also acts as a deceptive lens, completely distorting how we perceive heat and light. This brings us back to the famous million-dollar space pen. The story survives because it neatly confirms our biases about government waste and over-engineered solutions. The actual engineering constraints of spaceflight are much less forgiving. Pencils release highly flammable graphite dust and wood shavings, which become catastrophic hazards inside a capsule pumped full of pure, pressurized oxygen. A private manufacturer named Paul Fisher recognized this problem and spent $1 million of his own money developing a sealed ink cartridge, pressurized by nitrogen, that could function perfectly in a vacuum. Once it was tested and proven safe, NASA purchased them for about $6 apiece, and the Soviet Union quickly abandoned their pencils, buying the exact same pens for their cosmonauts. We prefer the Erdem legend because we find human hubris much easier to believe than the rigorous, life-or-death precision required to survive off-planet. Our brains were never meant to calculate the mechanics of a vacuum, where you can fall forever without landing, or where heat comes from severe compression instead of physical rubbing. Dropping these myths is the required first step in understanding our actual position as a tiny island in space. If we look past the bright blue sky that shaped our biological common sense, we can see the stark black reality of the cosmos. The universe is under no obligation to make sense to a terrestrial primate, and its actual complexity is far more beautiful than the fictions we invent to feel comfortable.